Space is full of quiet, peaceful, and beautifully boring objects. Planets orbit their stars, stars burn through their nuclear fuel, and galaxies slowly spin through the dark void over billions of years. But hidden in the deepest, most ancient corners of the observable universe lie absolute monsters. Objects so mind-bogglingly energetic, bright, and violent that they literally strain the boundaries of modern physics. Astrophysicists call them quasars. A quasar, short for quasi-stellar radio source, is not just a big star or a heavy planet. A quasar is the hyperactive, ultra-luminous core of a distant galaxy, powered by a supermassive black hole containing the mass of millions or even billions of suns. As this cosmic leviathan devours gas, dust, and whole star systems, gravity compresses and heats the falling matter into a glowing, swirling accretion disk. This disk spins at nearly the speed of light, generating temperatures reaching hundreds of millions of degrees and shooting out blinding beams of radiation across the cosmos. A single, average quasar shines with the combined light of 1 trillion stars. It is literally brighter than our entire Milky Way galaxy, packed into a region no larger than our solar system. Thankfully, the nearest known quasar, 3C273, is safely positioned roughly 2.4 billion light-years away from Earth. It poses zero threat to our quiet little cosmic neighborhood. But what if, through some catastrophic warp in space-time, a fully active, supermassive quasar suddenly spawned right inside our solar system? Say at the exact orbital distance of Pluto, roughly 4 billion miles away from Earth. To understand how quickly humanity is completely doomed, we have to look at the numbers. When you hear that something is 4 billion miles away, you might think, hey, Pluto is super far. It takes light over 5 hours just to travel from Pluto to Earth. Surely a distance of 4 billion miles gives us plenty of time to prepare, build underground shelters, or launch a rescue spaceship, right? Absolute wrong. You see, the moment this cosmic titan appears near Pluto, the mass of the solar system is instantly, ridiculously rewritten. Our Sun, a respectable star containing 99.8% of all the mass in our solar system, suddenly becomes a microscopic rounding error. The quasar at Pluto's location weighs 3 billion times more than our Sun. In a fraction of a millisecond, the gravitational center of our entire solar system is no longer the Sun. The Sun, Earth, Jupiter, Saturn, and every single planet, asteroid, and comet instantly lose their stable circular orbits. Gravity acts at the speed of light. Within roughly 5 hours of the quasar's sudden appearance, its immense gravitational pull yanks on planet Earth with unbelievable force. But long before gravity physically pulls our planet across those 4 billion miles, the radiation emitted by the quasar reaches us first. And that radiation is where the true horror begins. You see, a quasar does not just emit pretty visible light. Its roaring accretion disk pumps out insane amounts of high-energy gamma rays, lethal X-rays, harsh ultraviolet radiation, and relativistic particle jets. As those first photons from the quasar hit Earth after 5 hours, the night sky does not just get bright. The entire sky explodes into a blinding, white-hot wall of light that is literally thousands of times brighter than the noon sun. To anyone standing on the night side of Earth, looking up at the stars, the sky instantly turns into a searing, eye-melting furnace. The light is so intense that you would not even have time to blink. Your retinas would instantly vaporize before your brain could register the image of the cosmic monster hanging over Pluto. Within seconds, Earth's ozone layer, the protective shield of gas that filters out harmful solar radiation, is completely obliterated. The high-energy X-rays and gamma rays strip away ozone molecules like a sandblaster stripping paint off a wooden fence. Without an ozone layer, raw, unfiltered cosmic radiation slams directly into the planet's surface, sterilizing plant life, frying cellular DNA, and cooking the upper atmosphere into a superheated plasma soup. With the protective ozone layer completely stripped away in a matter of seconds, Earth's atmosphere begins to undergo a violent process known as atmospheric escape. The relentless torrent of extreme ultraviolet radiation and X-rays from the quasar transfers vast amounts of energy into the molecules of nitrogen and oxygen in our sky. The upper atmosphere heats up to thousands of degrees, expanding like a giant popping balloon. Atmospheric gas reaches escape velocity and boils off into the vacuum of space, leaving Earth completely bald, exposed, and defenseless. Down on the surface, the oceans begin to boil violently under the intense thermal radiation. But this is not the slow, peaceful evaporation caused by a hot summer day. The water in the oceans absorbs millions of joules of energy per second. Entire seas transform into towering columns of superheated steam that rise into the dying sky, only to be blown away into interstellar space by the cosmic radiation pressure. Within 48 hours of the quasar's arrival, planet Earth has been transformed from a vibrant blue and green oasis into a charred, airless, bone-dry rock, glowing red from the heat of the accretion disk shining from 4 billion miles away. But while Earth is getting thermally roasted, the gas giants of our solar system, Jupiter, Saturn, Uranus, and Neptune, are experiencing a far more violent structural execution. Take Neptune and Uranus, for example. Being the closest planets to the newly arrived quasar at Pluto's orbit, they feel the full, crushing brunt of the supermassive black hole's gravitational gradient. The gravitational force on the side of Neptune facing the quasar is millions of times stronger than the pull on its far side. As Neptune crosses the invisible Roche limit of this giant monster, the ice giant is stretched out like a piece of cosmic chewing gum. Its thick atmosphere of hydrogen, helium, and methane is violently peeled away, forming a glowing, spiraling gas stream that spirals straight toward the quasar's accretion disk. Within days, Neptune and Uranus are completely torn apart, their planetary cores shattered and devoured by the black hole, adding even more fuel to the roaring quasar. What about Jupiter, the undisputed king of our solar system? Jupiter is a massive gas giant containing over 300 times the mass of Earth. But against a quasar, Jupiter is nothing more than a tiny marble falling into a cosmic blender. The quasar's intense radiation pressure literally strips away Jupiter's outer layers of colorful gas clouds, while its massive gravity yanks the planet out of its ancient orbit. Jupiter is flung into a chaotic, decaying death spiral. As it plunges toward the quasar, Jupiter is stretched into a thin noodle of plasma, a process astrophysicists call spaghettification on a planetary scale. When Jupiter's remains slam into the quasar's accretion disk at near light speed, the collision releases a shock wave of energy so immense that it briefly outshines the rest of the disk, launching a beam of lethal radiation directly across the solar system. Even our Sun, the ancient star that created and nurtured life on Earth for over 4 billion years, is completely helpless. Under normal circumstances, the Sun rules our solar system with an iron gravitational grip. But now, pulled by the superior mass of the supermassive black hole, the Sun is yanked toward the quasar like a toy boat caught in a massive whirlpool. As the Sun accelerates toward the cosmic monster, the tidal forces begin to compress and distort its spherical shape into a football-like oval. Hydrogen gas from the Sun's outer layers is ripped away by gravity, streaming across the void in a bright, white-hot bridge of plasma. The Sun is literally being siphoned, drained of its stellar mass long before it even reaches the event horizon. As the remains of the planets are torn apart and swallowed by the glowing accretion disk, the final tragic spectacle of our solar system begins: the execution of the Sun itself. As our Sun reaches the inner edge of the quasar's sphere of influence, gravitational tidal disruption forces reach their absolute theoretical maximum. The Sun does not simply fall into the black hole whole. The extreme difference in gravitational pull across the star's width stretches the Sun into a massive, trailing filament of superheated hydrogen and helium gas millions of miles long. This process, known as a tidal disruption event, or TDE, converts the mass of our star into pure, radiant kinetic energy. As the plasma stream slams into the quasar's accretion disk at near-light speeds, friction and magnetic forces heat the stellar material to billions of degrees. The resulting explosion of energy unleashes a global hyperburst of gamma radiation that illuminates the entire interstellar neighborhood for dozens of light-years in every direction. What happens to Earth during this final stage? Earth, now nothing more than a charred, airless ball of molten iron and granite bedrock, follows the Sun into the whirlpool. Long before the rocky core of our home planet reaches the event horizon, the intense tidal forces break Earth down into individual atoms. The iron from our core, the silicon from our mountains, and the ancient atomic dust that once formed humans, trees, ocean water, and cities are all ground down into a fine plasma soup. That plasma soup is swept up into the swirling accretion disk, accelerating to 99% the speed of sound, and eventually plunges past the black hole's event horizon, disappearing from the observable universe forever. A small fraction of the matter that once made up our solar system does not fall into the black hole. Instead, powerful magnetic fields surrounding the spinning singularity grab millions of tons of superheated plasma and launch it away from the quasar in two narrow, focused relativistic jets shooting out from the north and south poles. These relativistic jets blast out into deep space at near-light speed, carrying the pulverized remains of Earth, Mars, Jupiter, and the Sun out into interstellar space. In a weird, poetic, and dark cosmic sense, the atoms that once built human civilization are not just destroyed, they are converted into high-energy cosmic rays and beamed across the galaxy to seed distant nebulae billions of years in the future. Where the peaceful blue and yellow solar system once sat for 4.5 billion years, there is now only a terrifying, roaring cosmic powerhouse. The quasar sits silently in the space where Pluto once orbited, its massive gravitational well having swept clean a radius of light-years. Neighboring star systems dozens of light-years away feel the sudden gravitational disturbance and see a new, blindingly bright star appear in their skies. So, what is the ultimate scientific takeaway from this mind-bending hypothetical scenario? It reminds us just how miraculously safe, quiet, and perfectly positioned our solar system really is. We live in a calm suburban backwater of the Milky Way galaxy, far away from the hyperactive supermassive black holes, active galactic nuclei, and volatile star-forming regions that make up the wilder parts of the universe. Our planet has been allowed to orbit a stable, quiet yellow dwarf star for billions of years without being roasted by a quasar, torn apart by a rogue star, or blasted by a nearby supernova. The universe is full of chaotic, high-energy monsters capable of erasing entire solar systems in a heartbeat. The fact that we are here, sitting on a warm blue rock with a breathable atmosphere, able to ask crazy physics questions and make animated videos about cosmic destruction, is the ultimate cosmic lottery win. If you enjoyed this epic journey into the absolute extremes of astrophysics and planetary destruction, hit that like button, subscribe to Cosmic Clueless, and drop a comment below. What cosmic monster should we bring into the solar system next? Stay safe, appreciate our quiet sun, and keep looking up.